Hello everyone, and this video is gonna be exciting, and you can already see why. This thing finally came, and a lot sooner than Amazon told me. They told me it's gonna take till February. Well, it's January 19th, and it's here. The EVGA Epower V. This is an e-power done properly, and I'm gonna unbox it now, and I'm gonna ramble about it, because this is a very interesting piece of hardware. And yeah, this is the third video I'm recording today. This, like, I made the PCB overview of the 7970 Lightning this morning. I've just finished doing the video with the GTX 460 SoC, and then the door rang and this thing came. So, there's one more, the EVGA seal. It's gonna be the first time having a high-end EVGA product. Like, I have two EVGA cards, but one's a GTX 580 reference, the other is a GTX 670 for the win, which is basically a 670 on a 680 reference PCB. So, this one is gonna be interesting. So there's a little guide here. And then we have, attention, electrostatic sensitive area. Do not enter without proper electrostatic safety equipment. I'm gonna touch the ground of a power outlet. Oh yes, that's bigger than I thought. That's a good... I'm gonna get the 970. Good thing I'm not using that to render the video right now, because the other video I just recorded is rendering right now. So, that's the power I made. Well, one of the two I made. And that's what a e-power made by people who know what they're doing looks like. So, yeah, so this is the EVGA Epower V, 5th generation. I think it's the third that's publicly available. Like, there was I think it was the generation 4 that was never available, because that was like meant for GTX. No, it was the generation 3. The Gen 4 was the one with the red PCB, I think. So it has to be the Gen 3, because that was just like an 8-phase, which was meant for a 680, and it was like barely finished. And then the 780 came out, and then the 8-phase wasn't big enough for e-powering a 780. Because that's what some 780s come with stock. And they scrapped it, and then I don't know if it was the Gen 1 and Gen 2, one of the two you could also buy. So this is the Gen 5. So the Gen 4 was basically just a EVGA classified VRM as an e-power, which is like a 14-phase using international rectified direct feds. It's basically the same VRM that it was on the 7970 Lightning. And since I just made that video today, I still know the spec of that. So yeah, let's get the 970 somewhere else. Kind of here. Yeah, so this is not a 14-phase, this is actually a 12-phase. But we do get dual outputs. We still have 14 inductors, because the last two over here are memory. So we have dual outputs. We can both e-power core and memory with this thing, which is very nice. And yeah, so this thing is basically as kitted out as it goes. Yeah, so this VRM is a 12-phase, and then memory is a 2-phase. They all use... good question. It's using international rectifier power stages. Let's see if it is in here. I don't think they have... Yeah, I don't think they have any yeah, they don't have any specifics in the thing. But you can see it kind of on the front. So this is using power stages. It's not using IR direct FETs. It's using power stages. And it's, I think, either IR 3555s or IR 3575s. I do not want to take this apart just yet. Like, this was kind of expensive. This was, well, I paid, what was it? I think it was $100 plus another 10 shipping. Which actually now I actually paid 10 more bucks than I had to, because the day after I bought this, it went down to 90 bucks, like euros. It's a bit more in US. I think it was like 107 US dollars. Now it's down to 90 euros, and I paid for it 100. So yeah, it's gotten even cheaper now. So including shipping, you can get one of these for 100 euros shipped now. And I think, like, if you're thinking about doing e-powers, yeah, now I actually just realized the camera is filming this way up right now. Well, that's gonna be fun in editing. Yeah, so if you're planning to do e-powers and you want like you need something more powerful than this, or you just straight up don't want to deal with making one of these, $100, one of these? It's like a really good deal in my opinion. Like, get one of these then. And like it's not like the Gen 4, which is just one output. Like, it's dual output, and it has this control area right here. So for the Gen 4, I think you had to either volt mod it, or you had to own an EV bot to actually have any voltage control. This one has an integrated EV bot. You can still attach an EV bot here, but I think, like, I've read the manual for this a while ago. I think the EV bot you connect here is just like as a remote. You can also connect a Raspberry Pi to this USB-C slot and do the same thing. I don't know what this up here is. This might be like a multimeter probe points? Yeah, it says probe. It's a probit connector, yeah. I think EVGA sells an adapter for this. But you have voltage readouts right here for core and memory. And then you have, yeah, those are just like the EV bot, like return, enter, left, down, right, up. Like literally just EV bot simulator. Yeah, then we do have 3 6-pin connectors, though I have to say that these are not normal 6-pin connectors. These are wired like 8 pins. So on a normal PCI Express 6-pin connector, you have 3 12 volts and 2 ground, I think. Yeah, you have 3 12 volts, 1 ground. And on an 8-pin, you have 3 12 volts, 3 ground, and then 2, like, I forgot to mention that, like a normal 6-pin. 3 12 volts, 2 ground, 1 sense pin. The sense pin is used to detect if you actually plugged in a cable there. So some cards, if you don't plug in a cable, you just see on the screen power down and connect PCIe power connectors for this graphics card. That's what this sense pin does. On the 8-pin, you have 3 12 volts, 3 ground, and 2 sense pins. One is for detecting the main 6-pin portion, and then the other sense pin is for detecting the extra 2 you have on your 8-pin. So yeah, these right here is 3 12 volts, 3 ground, no sense at all. So these have the same, like you can see it here, these have the same power capability as an 8-pin. And you should probably plug in all 3 of these. Because if you, okay, it's probably gonna be fine on 2 connectors unless you try to e-power something really power hungry, like say a 780 Ti, and run it close to 0 or under it. For everything else, it's probably gonna be fine on 2. But yeah, better plug all of these in just to stay safe. Then more features. We do have 2 fan connectors right here, which is just, well, you can connect fans to that. If you have like a custom heatsink on your GPU, you can do that. We have some switches over here, which It does say 7P. It said switch 1 to left for remote sense. Okay, yeah, it has droop control, force, voltage, offset. I think, yeah, it enables offset mode. Like, I should read the manual for this. Yeah, and then this chip right here, that should be our PWM controller. What is that? It's an IR3595A. Yeah. So actually, do we have a second controller? Is this controller both controlling our core and memory? I think so. I don't see a second controller. So this is gonna be a 12, like this is gonna be a 14 phase controller. It's running in 12 plus 2 phase mode. Yeah. So this actually, I don't know what the current rating of these power stages is. I think in raw current capability, the best VRM I own is actually the very, very big 8-phase on my 2080 Ti, which is using 2 power stages per phase. Because those are 70 amp power stages, and I have 16 of them. And here we have 12 with, I don't know if these are, I think these are 60 or 70 amps. So in theory, the maximum current throughput of this is actually lower than my 2080 Ti, but the thing is, it's still like a lot. Like, does it say it in here? Rated capacity is 600 amps. Or like, maximum peak capacity 620 amps at 1.85 volts. That's a lot of watts. Voltage adjustment range is 600 millivolts to 2 volts. Rated capacity 600 amps. Yeah. And we have it more. Rated capacity 80 amps. Wait, are these 40 amp power stages? Or is it just... I'm bad at math, I can't divide this by... Like, no, actually, 600 times divided by 12 is 50. So, are these 50 amp power stages? Or like, maybe it's like they rate them for actually running them at, like, because the thing at like 70 amp power stages, you're never gonna run at 70 amps, because then they're gonna kick out so much heat and they are uncoolable. So I don't know if that's the the rating of the power stages multiplied by how many there are, or if this is just like, yeah, this can sustain this. I think this is probably meant as, yeah, this can sustain this. Yeah. And minimum requirements, minimum rating for power supply 800 watts. Well, I have a 750, but I'm not. I was thinking of hooking this up to my 780 Ti reference card, but I'm gonna put this onto the. I could just bring the card. Like, let's just bring the card. So this is what I'm gonna put it on. My straight up from NVIDIA GTX 580 reference card. Already volt modded, but like that's not gonna be used anymore when I e-power it. So this does have a really good core. I think I ran this at 1067 or 1075 core. No, I think this did 1067. I think the 1075 is from my second Lightning. So yeah, that's a pretty impressive core clock for like a reference PCB. And the memory on this is also Samsung eDie. So this is gonna scale with voltage. I don't know if I'm gonna e-power memory as well, but I'm gonna e-power cores. Like, this is a 6-phase with... As far as 6 phases go, this is a pretty good VRM, but not for powering one of these cores. So yeah, I'm quite literally doubling the phase count by using this. I don't know if I'm gonna double the current capability, but it sure as hell will be enough. So yeah, what I'm gonna do is I'm actually gonna have to remove this capacitor, which is a... Yeah, that's an SMD capacitor. So that's gonna be easy to remove. I'll remove all the inductors, probably the CLJ 8266 as well, so it doesn't pull down our enable for like memory. And then gonna solder it to the card a bit like this. And yeah, then that's how I'm gonna e-power this. So yeah, talking about actually e-powering it. So how would you hook this up if this is the first time you see an e-power? So you have these outputs. The big one here is labeled VCC, that's our V-core output. And then we have ground, like this one here is ground, this one is ground, this one is probably also ground, or this will be ground. And then we have here our VMEM memory voltage output. You're gonna solder things like this. This is copper wire, this is 2 millimeters diameter. I do not know what wire gauge this would be, but quite literally the very same stuff was used by Der Bauer to e-power A1060. So yeah, this is probably good. As you can see, for my first e-power ever, which is this card, I used some 14 AWG wires. But I want to switch to copper, because first the stuff is more sturdy, and it's it's solid core, while the wires are like not solid core. So yeah, the only annoying part of this is it has like a protective layer, which is good for not causing short circuits, but it's really annoying because you have to remove it from where you want to solder this, and yeah, it's kinda annoying to remove. But this is what you would ideally use to attach the e-power, and I'm gonna do this because it's actually not heavier than this one, but it's quite a lot bigger. And well, I've managed to attach this kinda like, it is pretty rigid, mostly because of this one copper piece here. But yeah, I do not want this flopping around, because this cost me this e-power cost me roughly 15 euros and a couple hours of work, which I'm happy to put in. This cost me 110 euros. And I would very much not like to break it. But yeah. And then yeah, keeping to talk about the VRM, like, haven't talked about the output filter yet. Of course, the output filter is effing massive. So also the input filter is like, it's a giant amount of input filtering. So we have some Nichicon FP caps, 821 microfarads, 2.5 volts on the output. Doesn't say how they are rated, but well, like, these are enough. Then we have a lot of 470 SMD polymer capacitors, and also a load of multilayer ceramic capacitors. And we have some 330 microfarad pause caps for our memory. That is a lot. More on the back, like a load of multilayer ceramics, more pause caps for the memory. This is probably for the VRM circuitry. This is probably not output filtering. Yeah, so this is... yeah, this is a proper e-power, and I think it's the only e-power you can actually buy right now. I don't know, you might find like an e-power 4 on eBay. I am actually thinking that an e-power 6 is about to come out, because this is an MSRP of I think $250 US, which is gonna be something like 230 to 220 euros. Considering I got it for less than half of that, and it's gone down in price even more since. I am thinking EVGA is trying to get rid of their stock, or at least I got this from Amazon, so Amazon at least is seemingly trying to get rid of their stock of this. Possibly because there's an ePower 6 coming in, which, I mean, 1390 power consumption on LN2, I actually don't know. I know they have a very high power consumption spikes on ambient. I do not actually know how they behave on liquid nitrogen. Same for 2080 Ti's. I don't know if this would Yeah, actually, I think this was made for 980 Ti's and 1080 Ti's, and I think 1080 Ti's are like 700 watts on LN2 with like peaks at 1200, 1400 watts. Like, I think this says somewhere in here it's for GM200 and GP102. Here. Good rule to follow. One pair of wires per each 10 to 15 amps for simple VGA, like 2 to 3 phase VRM. Okay. Top GPUs like GM200, GP102 must use as many pairs as possible physically. So yeah, like this was out before the 2080 Ti, so of course the TU102 GPU is not listed here, and the 3090 is even newer. So yeah, there could be an ePower 6, which might have a 14 or even 16 phase VRM again. But I'm pretty happy with this already. Like, I'm not about to ePower a 2080 Ti or 3090 or anything like that. Like, I don't have that kind of money. Yeah, so like as I've said, the ePower is going onto this card. Because it has a really good core, it has nice memory that's gonna scale. And like this is a reference PCB, the VRM will quite literally blow up if I shove too much voltage into it. And also just the VRM performance will be a lot better when using this instead of the reference VRM. And then, yeah, like other cards I was considering to use this for was the 780 Ti amp from Zotac, which is just a reference PCB. Same thing for the 580, the VRM is just gonna blow up if I push the card. And then there's also the GTX 670 for the win, which is on a 4-phase, which probably, like, the 670 core doesn't consume that much power, but I would still like a better VRM. But I think if I ePower the 670, it's gonna get one of these boards instead of this. Because this is very much meant to be used with high power consumption cores that draw a lot of current. So yeah. And so, anything more to add? I don't know if there's anything more to add to this. Yeah, I have an ePower 5 now. And I can't say how long it's gonna take until I use it. Like, I don't want to break it. I don't want. It's like really precious to me. But like it says in here, it's just, where was it? It's covered only by dead on arrival warranty, which means I'm gonna test this right after filming the video. Yeah, but like this is meant to be abused, so to say. Like you're gonna solder to this, you're gonna put this onto cards, and you're gonna ePower them with this. So yeah, and like I mean, if you want to ePower a card and you don't feel like making one yourself, or you just need one that's more powerful than the 580 boards that I've been making, this right now, for the price I've bought this and the price that's no lower since, this is an absolute steal, I think. This is like, get this. Like, you should buy this, I think. Like, yeah, you can get it for 100 euros shipped if you're in Germany right now. Probably the same for the other regions. Like, this was shipped from the US. Like, this didn't came out of a German warehouse. This came from Amazon US store something. So, yeah. And yeah, so absolutely pick this up if you want to. Like, $100 might sound a bit much for literally just a VRM, but considering how powerful of a tool this is, I think this is well worth the money. Like, that you can even buy this is quite cool. Like Gigabyte, Asus, Galax, they all make their own e-power boards, but you can't buy them. I think you could buy the Galax e-power board at some point. That actually has a 16 phase and it's even more powerful, but I think if you were even able to buy those, you can not buy them for a long time anymore. And then the Asus and Gigabyte ones, they straight up were never available. Just like their Bauer got his hands on some of these because like he's an extreme overclocker. So he has his connections. He goes to events, and there's where you get these. But for just normal hardware enthusiasts, which I would say I am. Like, I haven't done liquid nitrogen yet, neither have I done dry. I don't even have an LN2 port. Until I do that, I'm not gonna call myself an extreme overclocker. So that's how it is. Yeah. So for normal people, this is pretty much the only option, except for making one yourself, which I would encourage, like, everyone who wants to try, I would encourage people to do that. Like, chances are someone already tried to make an e-power out of that card. Like, there's a lot of e-power guides out there, and even if not, like, it's not that it's very much different from card to card. You more or less do the same thing. But yeah, if you want one pre-made, get this. You have a guarantee it works, and it's really damn powerful. So yeah. 26 minutes. I should stop the video now. So, thank you all for watching. Third video for today. About a legitimately very cool piece of hardware. I can't wait to use this. But I'm also kind of scared I will break it. Which is why I'm gonna be careful. More careful than fast with this. So yeah, thank you all for watching. Hope you enjoyed. And until next time. Goodbye.